Okay, so this is the video solution for question number 1 of the formative test that we had last week. Right, first of all, looking at the question, it's important to have a look and identify your strategy, so how you're going to approach the task. Now, I would look at this initially and think, right, there's a line of symmetry running on a plane which runs from end to end. We've got a 60mm wide component and the holes are sitting on the midline 30mm from one side, so there's a symmetry running straight through it that way. Also, if we look at it from the side, there is a single profile which is then modified with the holes and the fillets on the corners. So I think I'm going to approach it by first of all drawing this profile shape that we can then extrude, incorporated in the symmetry line. There are many other ways of tackling the problem. You could model the base and then start building elements of it up this way, but the solution that I'm going to provide is detailed as I've just explained. Okay, so let's start by creating a new document. Right, starting point. I'm going to start with a plane, drawing a sketch on the front plane. And I'm going to roughly draw out, starting from the origin, my shape. So I'm putting the inferred relations, horizontals and verticals, and collinear relations. And there we have a rough outline of my component. I now need to finish that by adding the smart dimensions to get the appropriate sizes. So overall length, which is 150. You can see this is changing the look of it somewhat, but this will sort itself out as we go through. So 65 at the top. Now I can see that the relation, collinear relation that I need on that end is no longer present. That should be all the dimensions that we need. I'm going to now add in relations, so those two want to be collinear and equal to each other. And lastly, actually, those two need to be collinear too. Right, why is that errored? Oh, hang on, yeah, right. I still had these things selected. Clear selections. Collinear. And the last one, overall height. Which is 55. Now you can see I'm fully defined with all the dimensions and relations appropriate. Finish the sketch, and I'm going to choose extrude, and because of the line of symmetry down the middle, I'm going to, just to make it simple, choose mid-plane extrusion, type in the required amount, and it's our basic shape. Okay, so time for the circles. Now I'm going to draw them on the bottom and do an extrude through all. as this is a shared common plane. So sketch on the bottom face, one and two, choose the two circles so they're equal to each other in size, diameter 25, and then lastly I need my dimensions, so it's 30mm from that end, 25mm from that end. Now notice that they are still underdefined even though I had an inferred tracking point on there. If we add a relation between that and the front plane, oops, not that dimension, and coincident that, and do the same on that end as well. Now that's fully defined, do an extruded cut through all to create our cut points, and then the final little bits will be to put the fillets. Now a 10mm fillet on the corners when looking at it from above, and a 5mm fillet on these blend areas here. So put those ones on first. Separate fillet, 5mm, and that completes the modelling aspect. Now if I look at the bonus question, it asks what is the mass in kilograms of the component when made from carbon steel, plain carbon steel. And for that, first of all, I need to define the material of the component. Obviously, a change in material has an impact on the mass. So at the moment, the material is saying not specified. To add a material, right-click your mouse button on this message, and you can either click Edit Material and look at a full list of materials which are available within SolidWorks. There are all sorts of different categories that you can use. Alternatively, there are 10 most recently used or favourites that appear straight away, and plain carbon steel is on the top of that list, so I can pick it directly from that list. To get the mass properties, I go to the Evaluate tab and just click the mass properties button, and this is where I find the mass. So I've got a mass of 1052.62 grams, which equals 1.05262 kilos. 1.05 kilos would be suitable accuracy. And that is the end of question number 1.